Two massive stars are about to collide. As they get closer, they'll rotate each other, and they'll reach a rate so fast that they'll be going around each other 1,000 times every second. When they collide, they'll release the energy equivalent to a quintillion nuclear bombs. Einstein's theory of relativity predicts that this will send ripples out through the fabric of space-time itself, and when they reach you, they will distort your planet, they will distort your bones. What do you think will happen to you? You won't notice, because gravitational waves, which is what we call them, these ripples in space-time, are really, really small. But understanding them could help us understand the origins of the universe. So I'm going to use me as an analogy. How small are they? Look at me. Zoom in 1,000 times and you'd see this spot on my chin with horrifying clarity. 1,000 times again and you'd see my skin cells. 1,000 times again and you'd see my DNA. And 1,000 times again and you'd see the carbon atoms that make me. But this is where I run out of useful analogies, because you'd still have to zoom in another 10 million times before you got to the scale of a gravitational wave. Now, finding things this small, which is what I'm trying to do, creates really big engineering problems. In fact, we've had to design the most sensitive instruments ever built by mankind. They are so sensitive that ocean waves crashing against the continental shelf 200 miles away cause a bigger signal than those we're looking for. They are so sensitive that rain clouds floating overhead exert enough of a gravitational pull to distort our apparatus. They are so sensitive that we have to account for the vibrations of the atoms in the detector themselves. But after 50 years of research by a lot of people, we think we're about to find them. The latest generation of detector is currently being commissioned, and when it turns on next year, we'll be pulling back the curtains onto a really special new window into the universe. Because what we are building is a new sort of telescope. Existing telescopes, well, they look at light, radio waves, X-rays, but all of these things, as they travel through space, are blocked out by stuff, and that limits how far we can see. Gravitational waves, on the other hand, are simply contractions and expansions of the space itself, and they are therefore blocked out by nothing. This means that over coming generations, as these detectors get better, we will be able to see further into space, and therefore further back in time until we can probe the very origins of our universe. Now, Isaac Newton once said that he only achieved so much by standing on the shoulders of giants. Well, there is a lot of us standing on Einstein's shoulders right now, and it's going to give us one hell of a view. So, thank you, Albert, and thank all of you for listening.